This series help us to share and compare ideas between projects and to understand what are the possible solutions that all our projects are involved and would like to adapt. So we will talk about digital tools, human-centric thinking, and teamwork. The idea is that at the end of this series of webinar, we will create a new collaboration between us and find ways to work all together. The project involved are RaRe, Regroup, FlexPorRes, Accurate, AGILEHAND, and Credit. So what we will see today? First of all, we let's know each other. So we will do the presentation of all the projects, so the domain, the consortium, the major objectives of all the projects, and the digital solutions that are involved in every project. Then we will have a moment of discussion with we could understand if can be some synergies between us or what are the expectations of for our webinars. Just some words about Synergies. Synergies is an innovation hub, and we work with digital, circular, and collaborative innovation. So our aim is connect SMEs, organization, and research center, providing some methods, tools, and solutions for the innovation. So we are part of RaRe project and we work on the task of clustering activities, and so we organized this webinar for this reason. So we can start with the first project that will be RaRe. If you have some question or comments, you can write down in the question and answer section, and then we will read them at the end of the section. So thank you. Alexander, if you want to start with your presentation, please go. Thank you.
Fine. I will try to share my screen.
Yeah.
So first of all, I hope you can hear me and
yes,
also see the screen.
Perfect.
Fine.
Yes.
So,
Yes.
Alessandra, thank you for your introduction, and good afternoon to all the participants of our webinar. My name is Alexander Dementiev. I work at Fraunhofer Institute for Machine Tools and Forming Technology, where I'm the project coordinator of the RaRe² project. I will report today some main main details about our project. So our project focuses on supporting the human-centered agile reconfiguration of production and value chains, all in the changing scenarios. Our project started at the end of 2023 and has now reached its peak, I would say, where we can already see the first results and effects in our selected use cases. So we and our partners developed or implemented prototype versions of the tools in the project, and these are currently being rolled out. So our tools are, first of all, the error detection tool to recognize some demands in case of changes in the supply chains or manufacturing environment. Then we also a lot digital for process optimization in case when the manufacturing systems should be reconfigured. So next tool is the human-centered upskilling and upskilling tools to support our person in common sense in case of some changed workflows. So the next tool is the human-centered and data-driven decision-making to support the decision makers also in case of changing of environment situation, manufacturing situation. And then we also have our use cases. So one of the use cases is, for example, the use case from SIGSIS. I will exactly here calculation tool. I will introduce in short our use cases. Really short, yeah. Our production partner Fontana is dealing with the car body production. We have also Cavala from Fontana is from Italy, yeah. Cavala is from Poland, and Cavala focus on the child seat production. So the next use case partner is MMM from Netherlands with mobile sterilization units production, and the next production-based use case is from Netherlands. Sorry. MMM is from Germany. The next use case with the production background is SIGSIS. It is a kind of co-creation. We also want to use for our exploitation. Now, really briefly, so first of all, our original vision was for a unified IT platform for the development of a unified IT for the reality of industrial development. And the changing transformative step, so the development of a holistic methodology framework that also can support a wide range of digital platform variants. Yeah, we cannot our tools a unified approach, unified methodology framework. So lessons learned are especially like decentralized architectures are more flexible. And could is crucial for improve of the implementation, and the importance of the data availability and the alignment of semantic models for different use cases is also really time consuming. Probably lessons learned in short, if you want to offer human-centered solutions for production, for manufacturing, we must not forget the people, the stakeholders during the development phase. So my expectation in the next 2 meetings are probably to know more details on the implementation of reconfiguration approaches or tools from the other projects, and probably more details on the used or built IT landscape. Yeah, it would be really interesting for us, and also the reusing possibilities for reusing of such solutions. Yeah, it would be also really interesting for us. So thank you for your attention. Also presentations too.
Perfect. Yes, thank you, Alexander. Thank you. We can go on with the second project, I think. So please, from RaRe Group, Andreas, you can start with your presentation. Thank you.
Yes. Let me see if I can share here. I'm not really allowed to. Give me a second. So you hear me? Can you hear me? No?
Yeah.
Yes,
Oh,
sorry,
yeah.
I was mute. Yes, we hear you and we see your presentation.
You see the presentation, and if I go to the show mode, you still see it, right?
Okay.
Can you follow it if I skip the slides now?
Yes.
Yes.
Oh,
Yes.
okay. Thank you
Yes.
so much. And sorry for apparently
Don't
there was some
worry.
blocking in the settings there, so I was kicked out. No, I am here to present Regroup, resilient and rapid configurable production process chain. So Regroup or Art Regroup. The project started in January 2023 and will end in December next year. So we are almost 3/3 through the project by now. So there are definitely some lessons learned. My name is Andreas Dubois. I am project manager and tech transfer specialist from Fundingbox, one of the partners in the program. We're dealing mainly with the collaboration in between the developers and the industry. And yeah, we are part of this program. So the consortium here consists of 24 partners, led by IPC. We can somehow divide the different partners within the consortium into being developing partners, developing specific reconfigurable and automation solutions within the manufacturing sector, and then pilot companies that are testing these in real environments. So they're putting up facilities, they are doing the pilots, they are defining the use cases, and in close collaboration with developing partners, they are developing the specific solutions and testing them as we go. And then obviously there are always a couple of transversal partners where Fundingbox, where I am, are part of, let's say, expanding the ecosystem, reaching the industry, but also other partners that either support the developing side or the pilot side or the general consortium as an ecosystem builder or through different networks. So the vision of Regroup is that we want to empower the manufacturing sector through rapid reconfigurability and digitalization, and thereby also enhancing agility and building a resilient supply chains, and being able to enable adaptation on unpredictable events. And the main way we are doing this is obviously by carrying out these industrial demonstrators or pilots in these diverse manufacturing sectors. So we're trying to address real-world reconfiguration challenges with specific solutions developed, but in a tandem in between developers and testers dealing with this. And the sectors where we are testing right now is the five pilot demonstrators partners, which is automotive, fabricated metal products, rubber and plastics, wearing apparel, and home appliances. So the specific objectives we have here is, of course, to build specific solutions, such as launching a flexible AAS-based platform for smooth system integration, to create these specific tools and technologies that are reconfigurable production tools within the production lines. We want to build a digital toolkit to quickly assess reconfiguration impacts by using digital twins. So entire tools and technologies on digital twinning and how these can be used in the reconfigurable situations. And then smart tools that can detect when and why reconfiguration is needed across the value chain and where and how to set in. And then, of course, at the very end, also to enable a multi-level monitoring and quality control to make sure that maintenance and overview and monitoring is available and to reduce reconfiguration risks. But these are, of course, the different stepping stones and the different objectives we have in getting to the ultimate goal, which is for the project to develop human-centered solutions and put a special focus on supporting the adoption of these novel technologies that we are developing within the program. So what is the actual approach to do this? Because one is obviously that prior to submitting an application, certain challenges were defined, and now we're starting off with the technological approach, which is to develop these kind of solutions that can solve the challenges, right? So they are on detecting changes and simulate scenarios in real time, or enabling the adaptation and having minimal downtime, or strengthening manufacturing resilience and flexibility. So a lot of fluffy words on what we actually aim to do, but how are we actually doing it? So of course, the technological approach is to develop these technologies and solutions that can do this, but then it is, of course, how we do implementation and how we impact the reconfiguration in the exact production lines, right? So a human-centered digital architecture, and then, of course, combining all these tools so that things works from the very beginning to the very end. So not just applying a single solution, but also the monitoring, also the way that things works around, and then, of course, to support the fast, reliable, flexible production reconfiguration, which comes down to where we are right now, which is the integration into the exact value chain, right? So one thing is, of course, developing the technologies and aiming them to solve specific industry challenges. Another thing is to test it throughout industrial pilots and use cases, and having the opportunity to have the developers and the users driving this pilot together as we go, to constantly making sure that things are redeveloped and advanced and being optimized. Then we do share all the outcomes and all the results of the project. We stakeholder engagement and cross-sector collaboration. So we try to see, like, okay, those challenges that exist here, might they exist elsewhere? What we are developing to solve in a specific sector, can we use that elsewhere? And then at the very end, when we start engaging also with the industry, we want to provide also the developers with a guided go-to-market and exploitation plan for the smooth adoption among the industry even after the project. And so how do we support them in reaching not only late development stages, but also start their commercialization stages? We do that by what we call the early adopter program, which is for us a unique opportunity for the manufacturers and tech stakeholders to not only do the pilots testing that are set up from the very beginning, but also to engage with tech stakeholders in the industry before the products hit the market. So early adopters will be able to apply, to test, and verify solutions with their insights, influence how the final tools will be looking like depending on their needs. So European manufacturing SMEs in various sectors have the opportunity to apply and test these programs as an early adopter program within the major project that we have here, in order to give industry feedback, in order to give different views on how the projects could be developed in order to fit the market better. So kind of a market validation program we're doing here. We have 11 technologies right now available. They are all on our Tech Finders platform, where you can find them and you can apply to become early adopters of them. And this is open right now. It runs until the end of October, and from then we will select the industry applicants. We will put them together with the developers. We will try to define specific use cases based on whether they are applying to have demonstrations, have trainings, have consultancy, or actually build a use case where they are going to actually test these things. And then based on that, we will try to follow up by figuring out exactly how did this work out, what are they interested in, how can we support the developers in reaching these next stages after they have actually finalized their projects.
Okay, thank you for this presentation. Very interesting. Also, this adopter program, maybe all the projects we will see after this at the end of this webinar. So we can go. The project is a text for rest. So please, you can.
Yes. Come from Microsoft. Manos Makopoulos, who is the coordinator of the project, could not be here today, so I will represent Lex4S. I hope you can also see my presentation.
Yes.
Okay.
Thank you.
Then let me go into presentation mode and start. So Flex4S, the main, let's say, goal behind it is to introduce data spaces into the resilience assessment and reconfiguration of supply chains. We are a project that is ending on the end of September of this year. The project has been running for 36 months. There are several companies involved, including Netcompany, Intrasoft, also LMS, and several others. There is a mix of research institutions, technology providers, and of course, manufacturing companies that are testing the solutions. The challenge is to improve adaptability of factories and supply chains amid disruptions. The goal is to enable rapid reconfiguration of production networks, and of course, impact is smarter collaboration, faster adaptation, and stronger resilience. How we're trying to do that? The idea is to use two key enabling technologies. Let's say the one is the concept of data spaces. We've tried to use both Gaia-X based and IDS based data spaces, and also the concept of asset administration cells, in order to develop resilience assessment tools for early detection or reconfiguration needs, and support decision making for the application of reconfiguration strategies. Finally, let's say the end goal of all that is to test and validate the integrated solution into the industrial pilot cases. In terms of pilot cases, we have 4. You can see here the 4 companies. The goals for each pilot is different. And also we're focusing on various, let's say, levels. So the higher being the macro level at the supply chain level, which is the constant reconfiguration of supply plans. Then we have the meso level, where we have 2 pilots, reconfiguration of manufacturing processes during production and production planning optimization. These pilots also, of course, start at the micro level, where we go down to even the tool of a specific resource. And there we also have the last pilot, the reconfiguration measures after a tool change. In order to support this, we have come up with, let's say, an architecture of a pipeline of services based on the data spaces. We are using 2 kinds of data spaces, international data spaces or IDS, and the Pontus-X ecosystem based on Gaia-X. We looked into try to merging these 2 data spaces. This proved infeasible for the project. So the best, let's say, that we have managed to do is to combine them working in parallel. And of course, we have the asset administration cells for access to data. We're using IDTA submodels. We have also created our own submodels. The resilience data submodel has been also submitted to IDTA so that it may be added to the repositories. And of course, we have also some relevant submodels for reconfiguration for the various levels. We have 2 categories of services, again, grouped by the various levels. So on one hand, we have the resilience assessment toolbox. This is for assessing the supply chain and the supply plan, for assessing the factory level, the shop floor level, and so on, to assess the resilience score of each, let's say, level. And then the reconfiguration strategies, that toolbox, again, with several tools for the various levels, that supports the users to apply the reconfiguration strategies that have been identified from the resilience assessment output. As I said, we have been working with AESs to describe basically our data, including also the data that is coming from our pilot cases. So we have several AESs that have been developed in the project, starting with the macro level where we have the production network, production master production plan, product identification. Then we go to the meso, the facilities, resources, and process plan, and of course all the way down to the micro level where we have more elaborated the resources, of course, that we have in the previous level, and also introduce the work order. You can also see at the right the drawing where the various levels fit together. Of course, I should note also that the AES of each level rely upon those of lower levels. In terms of lessons learned, we have the integration of data spaces. This in order to apply data spaces in any kind of project, there is an initial learning curve. Of course, once this has been completed, it enables secure federated compute data and data exchange. In terms of the help is proved essential for semantic interoperability. However, the practical implementation remains complex and time intensive. Of course, here works in order to be able to develop practical models. Reliable real-time data collection is critical. Manual data entry or insufficient sensor coverage limits AI model accuracy and delays decision making. Human-in-the-loop approaches remain necessary. Operational and situational awareness strongly influence reconfiguration. Standard configuration processes are lacking across sites, so current processes rely heavily on individual know-how and informal practices. Resilience assessment metrics must align with landed needs and be updated in daily workflows for having real operational value. Configuration services must balance automation, explainability, and trust. Emerging technologies such as AES, data spaces, federated analytics, and so on have low maturity, so industrialization requires close technical and organizational alignment. And last but not least, continuous training and documentation and knowledge sharing across teams to accelerate adaptation and increase system reliability. I believe the next one is our expectation. So what we would like to get out. We would like to share our insights during the project support the other projects, and we would like to get feedback on the last mile, let's say. This is it from my side. So, thank you everyone for your attention.
Thank you too. We can go on with the other project. So it is the turn of Accurate.
Now we are one of the Accurate project. Let me So we are a technology provider with an Accurate. I'm myself and also and we are providing data space technology for a lot of different we are for the FlexWise initiative we have just heard out, and yeah, let me introduce Accurate to you. We are building or trying to achieve resilience through manufacturing as a service, digital twins, and ecosystems. I hope you can see my presentation. The consortium itself consists of 11 parties. It's a good mixture of research institutions, enterprises like Airbus, and also technology providers, small, medium enterprises, which together try to achieve our goals. Our vision is to realize manufacturing as a service value chains through several aspects, trying to increase capacity, profitability, and sustainability through more flexibility and through more resilience in supply chains. And to achieve this vision, we try to deliver federated manufacturing as a service framework, data space and ecosystems, which will power multiple multi-level digital twin models of service value chains. And based this should all be done based on a human-centered decision support system to improve resilient planning, operation, and responsive value networks. So based on this vision and mission, we have a few core objectives. One of them is understanding and adapting to unforeseen events like the COVID pandemic we just had, and also to better and more swiftly adjust logistics to diverse conditions. This could be such a pandemic, but also some kind of disruption event. This together should strengthen the resilience through smart manufacturing. So also the competitiveness of supply chains or manufacturing as a whole, and of course having here circularity and sustainability in mind, and bringing this all together as a service, so economically viable. Yeah, and all of this, of course, in the context of Europe Horizon, should drive innovation, accelerate adoption. For this to we're developing actionability in real life environments. We have 3 pilot partners and their supply chains to actually evaluate and validate all the different components developed here. So one of them is from the aerospace domain with Airbus Atlantic, and then we are using the electronic supply chain of Tronico, which also supplies to some degree Airbus, but has also, of course, other customers. And last but not least, very important for Europe as a whole, the automotive supply chain. And here we are using Continental as one of the tier 1 suppliers out of different OEMs. And what is manufacturing? You want to put the is to have a paradigm, to have a new form of value creation, which is much more flexible. And in this context, we want to make manufacturing services viable, which are much more, which allow a flexible approach to manufacturing, so that it's necessary, and this enable various capabilities and so human-based and organizational, and it requires resources and knowledge and an organizational framework, which we are developing together in the project and the initiative. And here various together, we are trying to put this into the ecosystem for much more flexibility in case any kind of this can come up. And for this, various tools are necessary necessary digital twins of all of these artifacts platform, which I will mention in a minute. And yeah, so important here is to offer these kinds of manufacturing services. You need some kind of marketplace where this is possible. Which is part of the whole basis movements in Europe to not develop a new centralized platform, provide new kinds of dependencies from these platform providers and lock-in effects, and at the end, more or less the use of proprietary software. So for this, we have developed a decentralized marketplace, which allows for the consumption, and the offering of services, while together being responsible for the governance of this marketplace and having which conditions is able to join. And yeah, here of course you are able to not only share data or data services, but also share whole digital twins here, and doing all of this in a privacy preserving way so that any kind of intellectual property is not being compromised in this process. And for this, we are using the Pontus X technology stack, which was already mentioned in the Flex4S presentation before, which actually allows such a decentralized ecosystem where we can technically exchange data not only within the Accurate consortium, but really thinking of a whole European data market using the Gaia-X framework here for interoperability, and also being able to technically exchange data and services, for example, with the Flex4S initiatives and a lot more, which I can show you in a minute. And yeah, what's special for the Accurate marketplace and the Pontus X ecosystem as a whole is a data access approach called computed data, which really ensures data sovereignty on a technical way. For this, if a data consumer is interested in any kind of service or data artifact, he does not receive this kind of data in a traditional data transfer, but he is using computational access to the data, so the data owner can specify which algorithms are allowed to compute on his private data, which could be any kind of manufacturing data which might contain intellectual property. Then the algorithm can, in a containerized environment, abstract any or calculate any kind of insights which do not contain the intellectual property anymore, but are very valuable for the consumer nevertheless, for example, for predictive maintenance use cases or any other kind of insights. And then the consumer only receives the results of the computation. So the data sovereignty is preserved and also technically ensured. And yeah, talking about computed data, for one specific use case or done on one data owner, this can be actually scaled and can be used on different kinds of data sources for so-called federated learning or federated analytics. So for this, we also have use cases identified and also in pilot cases already tested, where we can actually pool different kinds of data from many data owners together, and so create a much bigger model. For example, in the context of AI training, this is very interesting because the traditional approach, how also all the big hyperscalers are doing it, they're pooling the raw data together in one big repository, but all the data from the different data owners in this context is being compromised, and also intellectual property is being to some degree attacked in the process. So this might be not the fitting approach for a lot of data owners. So they are aiming for the approach on the right side, which does the computation locally and then only brings the models together for the aggregation afterwards. And yeah, the Pontus X ecosystem I mentioned before has grown significantly over the years. So we are using the Gaia X framework for interoperability on a semantic level. But yeah, on a technical level, federated infrastructure is being used with different operators we see here in the middle, which are then responsible for different data spaces we can see on the right side. And here, for example, Flex4S, the initiative presented by LMS before is part of it, also accurate, but a lot of other different initiatives which all can exchange data seamlessly with each other, avoiding any kind of lock-ins or data silos in the process, aiming for a unified data market in the future. For this, a European manufacturing ecosystem is being started to being established. So a lot of different initiatives from the manufacturing domain are already part of it, and more are joining. And yeah, it's grown. It grew significantly over the years, and of course, all of your initiatives are also specific parties are invited to join. So this can grow more and more over time, and there are no restrictions in the sense of obstacles to join. Just feel free to reach out and we onboard you so you can make your first steps. You're very much welcome to do so. So computer data was already explained. Yeah, we are also part of the manufacturing days in Brussels, which will start next week. So feel free to reach out if you are also there. Otherwise, you can also write me an email. Happy to exchange also bilaterally, but very much looking forward to all the presentations already shown here and also to learn more from the upcoming ones. Thank you, everyone.
Thank you. Thank you very much. So please, now we can go on with the other project, so AGILEHAND.
Yes, you hear me right?
Yeah.
I hope I won't be kicked out when sharing the screen this time. It seems that it's working. Thank you.
Yes.
So I will present now AGILEHAND, a project that started in January 2023 and will end this December. So we are almost at the very end. So it's a 3-year project. The AGILEHAND aims at developing advanced technologies for grading, handling, and packaging and autonomously soft and deformable projects, specifically within the food manufacturing process, and as a strategic instrument to improve flexibility, agility, and reconfigurability of the production and logistics systems for European manufacturing companies. The AGILEHAND consortium consists of a broad range of partners. We have 21 here. So there are, of course, research partners, universities, the specific developing partners that are developing solutions. Again, we have pilot companies here. There are 4 specific ones, all within food manufacturing, but developed into berries, vegetables, meat, and fish. And then again, some kind of transversal partners that are overseeing other things here. So the 3 major objectives to optimize the food production lines here is to develop high flexible, resilient, reconfigurable, and agile production lines able to handle a variety of different projects with high precision, and especially deploying easy to program control systems capable of intelligently handling complex productions in terms of shape, size, materials, and stiffness. Which goes for these specific production lines, because even though that they are defined for a specific sector like fruit, there's really different situations, whether you're handling a berry such as strawberry or you're handling an apple. So there are definitely something here regarding reconfigurability that needs to be optimized, and that's the focus within AGILEHAND and the solutions developed here. And then, of course, to increase the productivity by enabling fast and accurate movement of work pieces, right? So through the production lines, ensuring that in-time delivery and reducing downtime when shifting from one to the other. Within the project, there are 10 developed solutions, and they are cataloged into 3 different categories here. Quite unique for the AGILEHAND project here is that since it's focusing on just the food manufacturing services, they can take a dig deeper here. And that means also that some of the solutions are co-solutions or supporting solutions on the specific technologies that are being developed. So that means that not all of the solutions developed here are standalone solutions. So as the main solutions are being developed and are being deployed within the pilots, sub-solutions are being, or supported solutions are being built on top to add even an additional layer of quality here, right? Some of these are self-calibration sensing solution to create the quality. It's robotic manipulation systems. So reacts to product quality, pickup, reorientation, different SOMs and deformable projects without causing product damage, and considering collaborative approaches, especially here in the food manufacturing, the causing product damage is something super fragile. So even though that pickers are super soft and simple, it's constantly picking different shapes and sizes and different firmness of products. So there's definitely a lot of things going on here in order to develop the specific solutions for such a specific production line as, for instance, fruit sorting and packaging. And then AI-based solutions that will allow for monitoring, adaptive control, and synchronization of production and logistic flows within the specific factory. So as I said, the solutions here, there are 10, are being cataloged or grouped into specific suites. So the suites concern smart sensing, they concern self-adaptive handling, sorting, and packaging, and agile, flexible, and rapid reconfigurability. So it's also that within each of these suites, there are standalone technologies and solutions, but there are also support technologies that can support on top of this, especially when also bringing this to the industry. One thing is obviously the pilots that have specific challenges and needs that are to be developed, and then a specific solution is built to solve that specific need. But for introducing these products and solutions to the markets, also having support solutions such as in the smart sensing suite, having data sets, having self-calibrating, having everything that means that you apply a full suite of technologies from the beginning to the very end, instead of just a single solution that needs to be integrated and adapted to whatever production line and things you have there, is definitely something that is advancing within this project, where the developments are also going hand in hand within the suites. So again, the approach is to develop these specific solutions that are based on the challenges from the industry and arising specifically from the pilots that are within the consortium. Then it is the impact on the production lines to verify and test these solutions within the specific pilot lines, adapting to whatever needs they have, constantly updating and optimizing the solutions, and of course demonstrating that this works in a real world of grading, handling, and packaging scenarios where these solutions are actually intended to become of use in the future, right? And then it is the integration into the entire value chain. So yet again, here we also have an early adopter program to face the industry as we go, instead of finalizing everything within the project lifetime and then saying like, okay, the development of the production of the solutions and products are now final. Now the project ends, it's verified, and then we go to the market. So involving already the industry at an earlier stage is crucial here, to have to gain and receive the proper market and user insights in the late stages of development, and not just after development. And then again, to build a go-to-market strategy and exploitation plan for adoption across EU manufacturing. So is it possible also through opening up an early adopter program, opening up towards the industry, that these solutions can be used elsewhere than the exact niche that they were initially defined for? So yet again, we had an early adopter program. I'm not going to talk much about this, but here it's also ended because we are at the very final stages here, and right now the use cases are ongoing, and the user feedback are extremely crucial for the later parts of the project, also for building the sustainability and the legacy of such a project. And important is also that all the technologies remain available on the platform towards the industry even after the project ends, so that the opportunity to come there, read about the technologies, what they do, understand them in a less technical, complex way, but actually see how they work and how they can benefit, read about the success stories that have been done throughout the use cases, and actually seeing that this has been tested in the real world with real end users is definitely some of the stories that builds the legacy and the sustainability of the outcomes and results of such a program. I didn't get to say before what was our expectations from this webinar and these and the upcoming ones, but obviously also the learnings and outcomes from the other projects, how we can benefit from working together, how we can build synergies from connecting and understanding each other, and obviously how we can succeed in having a greater impact in the actual industry than just within our small projects at the very end. So hopefully we can succeed in doing that together also. Yeah, thank you.
Thank you. Perfect. Yes, we will see after the last project if there is some synergies. So we can go on with the last project for this today webinar. So credit project.
Yes. Hello, everyone.
Hello.
Let me share my screen. I hope, and you will see my screen. I hope you can see my
Yes.
screen right now.
Yes, we
Okay.
see it.
Okay, let me start my parts. Actually, the project name is Circularity and Remanufacturing Enabling Digital Twins. The acronym is CREDIT. So the duration is 48 months. So it starts in the 1st of January 2024, and it will be finished 31 December 2027. So let me also introduce quickly myself. I'm been working in R&D at Profen for about almost 10 years. And I'm working as a control system engineer right now, and I'm also currently pursuing a PhD in mechanical engineering. So as Profen, we are developing satellite ground station in the satellite communication industry. Into these states, we have developed and delivered satellites ground station ranging from 0.5 meter to 7.3 meters to the end users. So for these credit projects, we are one of the 5 use case providers in this credit projects. So to create a digital twin of the antenna system that we develop in our in-house facility. So for the credit projects, we have 12 consortium partners. The consortium consists of total 12 institutes and companies, and Aidener and Soraluse and Ideco from Spain, and MTU from Ireland, Chemnitz also from Ireland, Profon Farplus, Turkish Airspace from Turkey, and Gorenje and University of Ljubljana from Slovenia, and IAD from Greece. So thanks to the companies directly involved in the industry and users, so the end user needs can be analyzed very well because of these all companies. So the projects will be implemented in this stage. We have requirements and specifications platform, credit data platform infrastructure, and see here in digital twin for the manufacturing, developing, and credit digital service and application. And of course, we also following this dissemination and communication of product development, and of course, an exploitation strategy and business development. So the main objective of the credit project are enable the circular remanufacturing of components and products, promoting sustainable manufacturing and reducing environmental impact. And the first objective enable remanufacturing of components and products towards circularity, ensure the interoperability and adaptability and future extendability of developed solutions. And the third one, the boost to transition of the sustainable human-centered manufacturing industries. And the fourth one, maximize project impact and future replication of the results. So we can see much more details in here. The main objective of the credit is to enable the circular remanufacturing of the components and products, and it's promoting sustainable manufacturing and reducing environmental impact. So the credit digital platform will integrate service to support remanufacturing activities such as decision support tools, traceability and quality control, predictive maintenance and operational support to the human operator. Actually, the project's digital solutions will be used to develop 5 different remanufacturing processes in various industrial sectors, each following specific objectives and overall demonstrating the developed solutions' high adaptability. So we can see the washing machine industry, the automotive industry, the telecommunication industry, and the aerospace industry as a use cases. And one more is also added, the CNC manufacturing industry, we can say. So from here, we can understand the whole digital platform as a glance. So this is our case journey, mapping our journey. This one is our case states and the interconnections guiding us toward all project milestones. Actually, the project starts from TRL 5 and we will have some development time in the for the TRL 6 we have some validation, and for the TRL 7 at the end of this TRL the projects we will have demonstration and evaluation activities for all of these 5 use cases. So the actually at the end of the projects we are also currently working at the commercialization possibilities after TRL. This one is also being evaluated and plans are being made for the using end user at the end of the projects as a TRL 8, maybe TRL 9. So one of our value chain is we have 5 use cases from 5 different industries. In the use case 1, you can see the white goods, the end user is the Gorenje facilities. So the use case is the automotive industry, the end user is the Farplus, and in the use case 3, the telecommunication sectors or satellite communication sectors, the end user is Profen, and the fourth one is the aerospace, Inlectat, the end user is Turkish Aerospace, and the 5 one is the spindle heads. It is used for the CNC machines. The end user is the Soralüse or IDECO Research Center. So we are seeing the whole 5 different use cases here. Actually, the benefits gained from real-time monitoring of antenna system is very important. And also it is valuable to able to identify potential problems during washing machine production using a digital model. So also being able to verify that the correct shape has been achieved in the production of the highly critical aircraft parts that is used for the Turkish Aerospace. Some of them made from fiber fabrics, so which may also be 3D printed. So it's very valuable tool thanks to the digital twin or digital model that we will be using our credit platform. So it's also critical to able to determine the lifespan of the machining tool that CNC machines use continuously, regularly, and to ensure that decision can be made during the manufacturing stage. It's also very important. The production process of automotive parts is also affected by split-second decisions, so everybody knows it. So many defective parts end up in the trash if they cannot be reused. So you know that's process. The digital production process can reduce material waste, and it will also impact all the manufacturing process. So at the end of the projects, we will demonstrate all these 5 use cases in the projects. For the antenna system, for example, you can see these 2 different antennas tracking the same satellites. So antenna systems are used for critical tests at certain times of the day. So the satellite command and control is being performed using these tracking antennas. Any malfunction that may occur could cause a problem for the satellite performing, especially it's missing in space. Therefore, it's very important to be able to predict and take timely action before a malfunction occurs in the antennas. Because of that, the real-time monitoring and real-time decision-making is one of the important process for such kind of these system. Because in general, we can say it's a robotic platform, but the objective of this robotic platform is highly critical, especially for the satellite operation. So we are seeing that this credit platform will be compatible with different technology. So we will plan to creating a general digital platform. So in here, we are much more detailed information about the antenna use case. So the schematic diagram illustrates how the system decision-making mechanism will operate using internal and external sensors tailored to the antenna system. So the antenna gets some information from this sensor. The monitor control is controlled by the operator. So the credit platform will be visible by the 3D CAD platform, and at the backside, the kinematic and dynamics will be run. The finite elements will be analyzed, and of course, we will use some of the artificial intelligence algorithms to predict, to understand the system behavior. So, of course, one of our main goal is to predict the maintenance time before the failure happens. So, for example, here, when performing actual satellite tracking, for example, in the left side, you can see the real-time calculation of the changing dynamics of the antenna system in the right side. The credit platform will do that for the antenna, because if we made these things, thus the both precise tracking for the antennas and the prediction algorithms are run with real time based on the dynamic prediction in various environmental conditions. It's also very important because the wind conditions can be changed, the temperature can be changed. So we have to track real time, and we have to make a decision in real time, and thanks to the credit platform. So I will also show one of the other use case example, and this one is one feature that will be available in the credit platform. For example, on the left side, the physical-based digital twin of the washing machine cabinets. So we can identify the possible crack on the housing. So based on the model parameters, estimate for the possible cracks in the washing machine cabinet. Actually, this one is, I just prepare much more technical information about our projects. Maybe for the dissemination or exploitation things, the other project members will say something, I don't know. This one is my part right now. Thanks you for listening to me.
Thank you. Thank you for the presentation.
You're welcome.
So maybe we can, after this presentation, we understand that each project have a lot of different technologies, but obviously all are working for find a new solution for new processes that can be more flexible, efficient, and collaborative. I don't know if listening to the presentation, maybe you have found some synergies or some common points between all the projects, or if there is some situation that can be similar and other that are very different. If there is some question, or if someone want to give some ideas of this, please. Okay.
Yeah, probably I could start with some idea to be discussed, and I would like to start from the last part of each project with the exploitation plan or exploitation ideas. So in our last review meeting, it was one of the main discussion points with our project officer. And for me, it would be really interesting to see how this approach, how the exploitation activities are planned, or what's the idea how we can exploit the results from the research project. Yeah, because probably in all the presented projects, some tools or services will be developed, and what's the ideas how we can exploit the results, how we can do from the technical developments, kind of products or services. Yeah. It's an open question to all.
Well, yes, it is, I think, very important, this point, also because in every project we work on the technologies, we develop some tool, some platform, but we think also the strategies for going to the market. And because the real goal is to have an upgrade of our processes in manufacturing, but also in the other sectors. So I think that this topic could be very interesting also for the second webinar, because in fact, in the half of November, we will explain from the technologies how this technology can be in the value chain. It can be inserted in the value chain, and so also maybe we can talk about the exploitation and strategies that can be useful to understand how also use case pilots can react of these technologies. Please.
Thank you.
Yeah.
Thank you. So my name is Burju. I'm working at the credit project along with my colleagues from Profen. When you asked about how different exploitation strategies the other projects use, or what kind of tools we developed or used, we recently, I don't know if your projects also use the service. We recently used the Horizon Results Booster and their services for supporting and enhancing our exploitation strategies. So it's a free service if you're not aware of it, for all of our Horizon Europe projects, or even for Horizon 2020 projects, that you can apply easily. An expert to exploit the results of your project, and then they create a very comprehensive report with suggestions for exploitation pathways and routes. I can say from credit's point of view that we were very happy with this service and use it. And our colleagues who are leading the exploitation work package is working from the results of this report to enhance our exploitation plan.
Thank you very much. Yeah, it's really interesting. We will try to do that.
Yeah, thank you, Alexander, for that question. I think it's definitely something to discuss among projects, right? As you say, we are all using tools or developing platforms to show the outcomes, right? And I think it's especially the developing platforms thing is a thing that we see over and over again, right? That within the projects we develop something that needs to pass on even after the project, and there we see something that someone are obliged to maintain websites or platforms or whatever for a certain period of time, 1-2 years, and then it ends. In our projects right now, we have as funding box built our platform for this. We are leading distributor of cascade funding in many other programs, and we saw that there was a need for this, but we also saw that there was a need for having someone having an ownership of such a platform. So we are dealing with it that way also as exploitation manager here within the programs. But I think more than just promoting ourselves, I think it's something that we need to solve in between the programs, because otherwise we will all build our small little exploitation plan or sustainability plan. We will share the results. They will go live. We will spend a lot of time on talking about them. And then eventually, after public funds and after our obligation times, and whenever all of us are with something else, this will end, right? So how do we do it differently? We do it right now in these projects in a way where we try to connect with the industry and try to establish that next stage or next step already before we end. It's part of a new group of projects, so I don't have long time experience, and I say like 5 years ago we did this and that was a tremendous success. But at least we're trying to do something a little different than from just writing a report saying like, these are the outcomes, here you have it as developer, and please then go and execute based on these recommendations. We will gladly take the discussion further, right? But I think definitely that creating synergies, having a common forefront on how we put these developments or results, outcomes, whoever or whatever it is, right? Is it learnings from these projects? Is it specific technologies that are being developed? I don't really. I still see the same issue for them, that they are presented publicly in each and every one of the projects separately, and then they eventually are not the hot stuff anymore.
Thank you, Andreas. Yeah, the idea of the early adopter program, I think it is really interesting. Yeah, really nice. We will think about. Yeah. Thank you.
Maybe I can add something regarding this issue. I thought that for this purpose, the organizations that we are active members, like associations, for example, can be used because as all of us realize that they have a wider membership network, and by using these platforms, it's possible to reach more people and possible to create synergies, as Alexandra said, and Andreas said, and by this way we can increase the impact of our projects. And I'm sure that within their membership network, there are a few people that are working on valuation or how can I say, exploitation, specifically on exploitation as a profession. So the different members can help, how can I say, high-profile members can help low-profile members to increase their impact, or to help them to, how can I say, exploit their project results. So I thought that the associations can be useful alternatives for this purpose.
Thank you. Thank you. Yeah.
Yes, I agree also with these points. Yes. I think that there are all points that are very interesting, and maybe we will discuss all these points in the next webinars. I don't know if there is some other question. Otherwise, we can stop this first event, and we can see in the next one.
Thank you.
Okay, so thank you very much for being here. I will send you all the information for the next one, and you will also find this registration online in the informal factoring community, but also in other channel. So thank you, and have a good afternoon.
Thank you.
Thank you.
Thank you. Bye, everyone.
Thank you very much. Bye bye. Bye bye.